Hi, welcome to my channel. In this video I am going to discuss the topic diffraction. Now suppose if I keep this pen above, there is a source of light, and as you can see the shadow of this pen is not perfectly dark, because see, light is coming. If this pen is blocking the path of light, this shadow of the pen should be perfectly dark, but the light is entering the region of this shadow. That means the light is getting bent. So this bending of light around the corners of obstacle is called diffraction. Okay, now diffraction, it is of two types. One is Fresnel and the other one is Fraunhofer. Fresnel diffraction and Fraunhofer diffraction. Now in Fresnel diffraction, source and screen, they are at finite separation, and in Fraunhofer diffraction, source and screen, they are effectively at infinite separation. Effectively at infinite separation. Okay, now in your NCERT textbook they have discussed this diffraction, Fraunhofer diffraction. Now effectively at infinite separation, why? Because they are not actually in source and screen, they are not actually infinitely separated. So let us see how this arrangement is. In this diffraction you have a single slit. In Young's double slit experiment you had two slits. Now in diffraction we will have a single slit, and there is a lens. This lens and this slit, they are placed in such a way that this distance is the focal length of this lens. So this is a biconvex lens. So light coming from this slit emerges out parallelly, and then it is incident on the screen. Okay, so since these light rays are coming parallel and parallel rays comes from infinity, so we can say that the source and the screen are effectively at infinite separation. Okay, now the light what we use here is the monochromatic light. Monochromatic, monochrome, that is mono means single, chrome means color. So monochromatic light means light of single wavelength, and on the screen we get a central maxima. This is central maxima, and the secondary maxima, the intensity gradually decreases. So this is the central maxima, this is the first secondary maxima, the second secondary maxima. So as you move away from the central maxima, the intensity of the maxima gradually decreases on either side. So this is the diffraction pattern. In interference all the maximas were of equal intensity, but in diffraction the central maxima and the other maximas, the intensity gradually decreases. Now let us see this arrangement of a single slit, and this is the screen, and monochromatic light is coming from this side, from S. So S is the source, and this is the slit Ln. C is the central point on the screen, and P is some other point on the screen. Okay, and this is one more point M. It is at the center of the center point of the slit. Now the light rays which are traveling in this straight path towards C, all these rays will have zero path difference, and at the central, so it is for this reason you have a central maxima in diffraction pattern. Then diffraction is bending of light. So light rays also bends and travels towards point P on the screen. Suppose this angle is theta. So theta is the extent of bending. Okay, Now if I drop one normal, this angle is theta, this angle is also theta, this is theta, and width of the slit is A. Width of the slit is A. Now if this is A, this is theta, this will be A cos theta, and this will be A sin theta. So for light ray which is traveling from L to P and from N to P, this is the extra path difference. So A sin theta is the path difference. So what we are going to analyze here is, see, basically diffraction is superposition of waves. Now in interference we had two sources, but diffraction we have only one single slit. So how we are getting superposition of waves here? So in diffraction, see, for this slit, so a wavefront, a light is emerging out means a wavefront is emerging out. So different parts of this wavefront, single wavefront, they will undergo superposition, giving rise to this diffraction pattern. So here, as we can see, for the light ray which is traveling from L to P and N to P, the path difference is A sin theta. Okay, so I can write it as, so path difference is N to P, so N from N to P, NP minus LP is equal to A sin theta. Okay, now for small theta, this sin theta can be written as theta, so this gives A theta. Okay, now if we consider 2 points, so see, this slit is first divided into two parts. One part is LM and another part is MN. Now in the upper half we take one point M1, in the lower half we take another point M2. Okay, such that these 2 points M1 and M2, they are separated by distance y. M1 M2 is equal to y. Okay, now when we take points L and N, which are separated by distance A, because A is the width of the slit, the path difference was A into theta. So for points M1 and M2 which are separated by distance y, what will be the path difference? It will be y into theta. So M2P, M2 to P minus M1P, this is the path difference, is equal to y into theta. Okay. Now for C, for light ray which are coming towards C, this path difference, this theta will be 0. So for C, theta is equal to 0. Okay, 0 means there is no path difference, 0 path difference. So that gives maximum intensity at C. So that is central maxima. Central maxima. Okay, so now we have found that intensity has a central maxima at theta is equal to 0. Okay, now other secondary maxima are obtained at theta is equal to twice n plus 1 lambda by twice a. Okay, and minima are obtained at theta is equal to n lambda by a, where in this case n is equal to plus minus 1, plus minus 2, plus minus 3, and so on. So this is the condition for secondary maxima, this is the condition for secondary minima. Okay, now let us see what is the reason behind this. Why this is the condition for secondary maxima, why this is the condition for secondary minima. Okay, let us see the explanation for this. Now for angle theta, okay, path difference is A into theta. Path difference is A into theta. Okay, now minima is theta equal to n lambda by a. Now for n equal to 1, we have theta is equal to lambda by a. Theta equal to lambda by a. Now this slit is of width a. So if M is the center point, this part is A by 2, this part is also A by 2. Okay, so if this part is A by 2, this part is A by 2, that means I can take one point M1 here, another point M2 in the lower half, such that those 2 points are separated by distance of A by 2. And there can be so many other such points which are separated by distance of A by 2. One point on upper part, one point on lower part, which are separated by distance A by 2. So for M1, M2 is equal to A by 2. What will be the part difference? M2P minus M1P is equal to, now distance is A by 2, so A by 2 into theta. But what is theta? Theta is equal to lambda by A. So that gives A by 2 into lambda by A. So A cancels out. So we are left with lambda by 2. So part difference of lambda by 2. The part difference of lambda by 2 is equal to phase difference of 180 degree. That is 180 degree out of phase. The two waves are 180 degree out of phase. If the two waves are 180 degree out of phase, they cancels out. So we get zero intensity. Zero intensity. So it is for this reason. This is for lambda theta equal to lambda by A. So in general we have condition for minima is theta is equal to n lambda by A. So this is the condition for minima. Now let's see what happens for maxima. For maxima we have written theta is equal to twice n plus 1 lambda by twice A. Okay, so for n is equal to 1, this theta is equal to 3 lambda by twice A. Okay, so now let us divide the slit. So if this is the slit, so we divide the slit into 3 parts. One part, first part, second part, third part. So this is the slit divided into 3 parts. Okay, now so this is the 2/3 part and this is the 1/3 part. Okay, so for the 2/3 part, what will be the part difference? 2 by 3 into A into theta. So what is theta? Theta is equal to this quantity. So 2 by 3 into A into 3 lambda by twice A. So that gives lambda. Okay, so if this is lambda, that means this part is lambda by 2, this part is lambda by 2. Now, if this part is lambda by 2, this part is lambda by 2, so that means again they cancels out. Now, if this part cancels out, that means we are left with this part. So only this, so when the slit is divided into 3 parts, 2 parts cancels out, intensity is due to this 1/3 part. Okay, so this is the first secondary maxima. Similarly, for n is equal to 2, theta is equal to 5 lambda by twice A. So now the slit will be divided into 5 parts. 1, 2, 3, 4, 5 parts. Okay, now each part is lambda by 2, lambda by 2, this is lambda by 2, this is also lambda by 2. So 1, 2, 3, 4, 5 parts. So these 2 parts cancels out, these 2 parts cancels out. So now we are left with the 1/5 part. So obviously the intensity when we had light coming from the 1/3 part will be greater than the intensity which is for the light coming out from the 1/5 part. So it is for this reason the intensity of secondary maxima gradually decreases. This is the central maxima, this is the first secondary maxima, then second. So on both sides of the central maxima, the intensity gradually decreases. This is the explanation for that part. So I have attached my handwritten notes, and after the end of this video you can take the snapshot from the notes and then you can write those things. This is 100% as per your NCERT textbook. So I hope this explanation is beneficial to you. Thank you.